Guide to Haccp hazard analysis and critical control points. Visual. Clean food production facility. People wearing protective gear, clean equipment, organized workspace. Voiceover. Welcome to our comprehensive guide on Haccp, or hazard analysis and critical control points. Haccp is a systematic approach used by the food industry to ensure food safety by identifying, assessing, and controlling potential hazards at various stages of production. In this video, we'll break down the essential steps of Haccp, explain its importance, and guide you through its practical application in food businesses. Scene 2. Graphic with Haccp acronym showing hazard analysis and control points. Voiceover. Haccp was developed to prevent food safety problems before they occur. It's a proactive, science-based system designed to minimize risks from biological, chemical, and physical hazards. These hazards can be introduced during food processing, handling, or packaging, making Haccp a vital part of food safety protocols. Scene 3. The importance of Haccp. Visual. Various settings in the food industry: manufacturing, retail, and restaurants. Food safety is crucial for public health. Implementing a Haccp plan helps businesses maintain high standards, protect consumers from foodborne illnesses, and comply with regulatory requirements. Whether you're in food manufacturing, food service, or distribution, Haccp helps safeguard your reputation and ensures that the food you provide is safe to eat. Scene 4. The 7 principles of Haccp. Each principle is highlighted on the screen as the narrator explains. Haccp is built on 7 key principles. Let's break them down one by one. 1. Conduct a hazard analysis. This first step involves identifying potential hazards at every step of your production process, from raw materials to final product. Hazards can be biological, chemical, or physical. 2. Determine critical control points, CCPs. A critical control point is a step where control can be applied to prevent or eliminate a food safety hazard. For example, cooking, chilling, or metal detection may be considered CCPs. Establish critical limits. For each CCP, you must set critical limits, specific, measurable parameters that indicate whether a process is under control. These might include temperature, time, or pH levels. 4. Monitor CCPs. Once critical limits are set, it's important to have monitoring procedures in place. This could involve temperature checks, pH testing, or visual inspections. The goal is to ensure CCPs stay within their critical limits. 5. Establish corrective actions. When monitoring shows that a CCP is out of control, corrective actions must be taken to fix the problem and prevent contaminated products from reaching consumers. 6. Establish verification procedures. Regular verification ensures that the Haccp plan is working as intended. This could involve equipment calibration, microbial testing, or reviewing CCP monitoring records. 7. Establish record-keeping and documentation. Comprehensive documentation and records are essential for proving that your Haccp system is working. This includes monitoring logs, corrective actions, and verification activities. Scene 5. Steps to implement a Haccp plan. Visual. Step-by-step infographic of the Haccp process. Now that you understand the principles of Haccp, let's talk about how to implement a plan in your facility. Here's a step-by-step guide to help you start. Assemble a Haccp team. Bring together knowledgeable staff from different departments to analyze risks and help implement the plan. Describe the product and its intended use. Understand the characteristics of the product, such as ingredients, shelf life, and how consumers will handle it. Construct a flow diagram. Map out each step of your process, from raw material intake to final product storage. Conduct hazard analysis and identify CCPs. Apply the first 2 principles of Haccp to your process and set critical control points. Implement monitoring and corrective action procedures. Develop specific protocols for monitoring CCPs and outlining corrective actions when limits are breached. Scene 6. Real-life example of Haccp in action. Visual. Footage of a real food production line, e.g. meat processing, dairy, bakery. Let's look at an example of Haccp in a real-world setting, a meat processing plant. After conducting a hazard analysis, the team identified the cooking stage as a critical control point because it eliminates harmful bacteria. They established a critical limit of cooking the meat at 165 degrees Fahrenheit for 15 seconds. Every batch of meat is monitored for temperature, and if the limit isn't met, corrective actions, such as recooking, are immediately applied. Finally, records are kept of the monitoring and actions taken. Scene 7. Common challenges in Haccp implementation. Visual. Busy kitchen, production line issues, challenges, and solutions. Voiceover. Implementing Haccp is not without its challenges. Some common hurdles include insufficient training, lack of resources, or inconsistent monitoring. However, these can be addressed with proper training, not adequate resource allocation, and a commitment to food safety culture. Working with experienced Haccp consultants or getting certified training can also smooth the process. Visual. Smiling employees, safe food products, satisfied customers, certification seals. Voiceover. There are numerous benefits to implementing a Haccp plan. It improves food safety, boosts customer confidence, reduces waste, and minimizes the risk of foodborne illnesses. Furthermore, having a Haccp certification can open up new market opportunities and ensure compliance with regulatory bodies. Haccp certification process. Certification process, audit, and approval. To obtain Haccp certification, your facility must undergo a thorough audit by an accredited certifying body. The audit will assess whether your Haccp plan is properly implemented and effective. Upon successful completion, you'll receive a certification that's valid for a specified period, requiring regular audits to maintain. Visual. Recap of key steps with a visual checklist.